Let's practice graphing a cosine function with translations together. Now, if you don't have a strong understanding of how to graph the parent cosine function yet, I encourage you to check out one of my previous videos where I go into that in detail. As we deal with this particular cosine function, I'm assuming you have some background information on the parent cosine function. And as always, if you'd like to download a free copy of this blank PDF or look at the annotated answer key PDF, you can find a link to that below. Let's get started. The function we're dealing with here is f of x is equal to cosine of the quantity of x plus pi plus 3. Let's see how this fits into our general formula for cosine functions. And we'll start by identifying our a, b, c, and d values. For this function, it looks like a is going to be 1 since we don't see anything in front. 1 times anything stays the same, so we're not going to see it based on that identity property of multiplication. So we have 1 multiplied by cosine. And now what about for b? Well, we see a coefficient for x is just going to be 1 here, so let's just go ahead and open up a bracket here. I'm going to go ahead and put a 1 in front. We don't see it, so I'm going to go ahead and just put a 1 there for the identity as well. And then we're going to have x. Now what about for c? Well, our formula has a minus c in here, but we have a plus pi, so that just must mean that we have a negative value for c, so I'm going to go ahead and write plus the pi here, but we know that c is going to be equal to negative pi. Hopefully you can see that if we don't write this 1, nothing changes. We have the same original value in here, or you can distribute that 1. You can see we're also going to end up with the same thing here. Finally, we have this plus d, and we have this plus 3, so we know the value for d here is going to be a positive 3. So for a, b, c, and d, a is going to equal 1, b is going to also equal 1, c is going to be negative pi, and d is going to be positive 3. Let's go ahead and write those in and then figure out what those tell us about our translations to this cosine function. First off, for the vertical reflection or flipping the function across the x-axis, we always are going to look at the a value. If a is a negative number, then we would have a vertical reflection, but since it's equal to positive 1 here, we're not going to have a vertical reflection. As for horizontal reflection, or a flip across the y-axis, that's dependent on the value of b. If b was negative, then we would have one of these types of transformations, but we don't, so we're not going to have a horizontal flip here. Alrighty, for the amplitude, that is dependent on the value of a. It's actually the absolute value of a, because sometimes a could be negative, but the amplitude is going to be dependent on this a value. In this case, it's just going to equal 1, so our amplitude is 1. Alright, as for the period, this one is going to take a little bit more work, but we use the value of b to help us find the period. So remember, the formula for finding the period of a cosine function is going to be 2 pi divided by whatever b is. In this case, b is equal to 1, so we're just going to go ahead and write 2 pi divided by 1, so we know the period is going to stay the same here, and that makes sense since the value of b is 1, it doesn't make any effect on the cosine function, so the period here is just going to be 2 pi. Moving on to the midline, that's going to be affected by the value of d. So typically the midline is just going to be at y equals 0, or that horizontal line along the x-axis, but we have a positive value of 3, so that means this whole function is going to be moving up 3 units. So our horizontal line here for the midline is going to be y equals 3. What about the lowest and the highest point of this function? To find the minimum y value for this function, we're just going to take the midline, which is y equals 3, and then take away the amplitude of 1, so 3 minus 1, that's going to equal 2, or positive 2 here. And then for the maximum y value, we're just going to take that midline again of 3. Let's go ahead and add the amplitude of 1. 3 plus 1 is equal to 4, so we're going to see here that the maximum y value for this function is going to be a y value of 4. Now before we look at our 5 critical x values for this function, let's go ahead and take a look at the parent function first. To graph the function that we're dealing with more easily, so remember the parent function for cosine starts up here at 1, goes down to the x-axis, goes down to negative 1, back to the x-axis, and then ends back up here at positive 1. This is what the parent function curve is going to look like, so we're going based off of this. So these are the 5 critical x values for the parent function, but we're not going to go ahead and use those here. We're going to have to find out our new ones for this particular function because of the translations. And of course, here are our y values or f of x values. So we start up at 1, we go to 0, go down to negative 1, then back to 0, then back up to positive 1. All right, so while that's the parent function, what about this particular function that we're dealing with? So for this particular function, we need to know that we moved this whole cosine function to the left pi units because of that c value. So all we have to do to come up with our new x values is take each of our original parent function x values that we have over here, and then take away pi from each of them or move them to the left pi units. So if we're at 0 and we take away pi or move to the left pi, that's going to be negative pi. Then moving on to pi halves, if we take away pi, that's going to end up being negative pi over 2. Over to pi, if we take away pi, move it to the left, we're going to end up at 0. Then if we have this 3 pi over 2 and take away pi, that's just going to be equal to a positive pi over 2. And then finally for 2 pi, if we move to the left pi, that's going to end up being at pi. So again, it's really important to look at our c value when we're coming up with our new x values for this function. Now, as for the f of x values or the y values, that's going to be dependent on the value of d. And since d is equal to 3, we just have to take each of our original f of x values and add 3. So 1 plus this 3, that's going to equal 4. And if we go ahead and take the 0, add 3, that's going to equal 3. For -1, if we add 3, that's going to equal 2. 0 plus this 3 is going to be 3. And then this 1 plus this 3 is going to equal 4. So now that we have a table of values for this particular function, we're going to take each of our x values and apply them over here. So for one period of this function, these are going to be the 5 critical x values that you would need to know. Then using those particular x values, we can just follow the parent function curve or pattern here, since we're not dealing with any reflections or stretches. All right, let's go ahead and graph this now. So here is where we're going to graph. I just went by pi over 2, or half a pi for each of these boxes going across, and then going up and down on the f of x or on the y values. I'm just going ahead by 2's here, just so we can fit our function. Starting with our midline, it's typically at the x-axis at y equals 0, but we had a d value of 3, so this midline is going to be moving up to positive 3 units, so that's going to be right about here. While this is our midline, we know our lowest y value is going to be at positive 2, so that's going to be 1 below, since the amplitude is just 1. And if our minimum y value is 1 below the midline, then our maximum y value is going to be 1 above the midline. Now we know where this particular cosine function is going to be contained. Now let's go ahead and plot our 5 points from our table. So remember, we were at -pi, 4, that's going to be up here. Then -pi over 2, 3, that moves down to the midline. Then it's going to be 0, 2, which goes down to the minimum. Then it goes back to being at the midline at pi over 2, 3. And then it's going to go back to the start at the end of the period at pi, 4. Now let's just go ahead and connect this using a smooth curve. So this right here are the 5 points we had from the table we had earlier, but keep in mind that these cosine functions are going to keep repeating themselves, so we can go ahead and continue this pattern if we want more than one period. So just follow the pattern and go back to the midline, then below, back to the midline, then above, back to the midline and below. Continuing this on the left side, we're going to go to the midline, then below, midline, then above, midline, then below. In case you had to sketch 3 of the periods, here are 3 entire periods for this function. Alright, so there you have a pretty detailed explanation on how to graph this particular cosine function that had some translations moving left and right as well as up and down. Now if you're ready to tackle some different types of transformations like reflections as well as stretches or shrinks, feel free to check out some of my other videos where I go into those as well. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.